So we're going to learn two different options on simplifying the third root of x to the 14th. Okay, let's start with the best way to do it, in my opinion. The best way to do it is to understand that any nth root could be rewritten as a rational exponent where you take your base, you leave it your base, but then you have an exponent that's really a fraction and the power goes up on top and the root goes on the bottom of your rational exponent. So in other words, x to the 14th with the third root of the x to the 14th, what's that going to change to? X to the 14 over 3, right? It's always power over root. So that's what we end up changing it to, x to the 14 over 3. Now, from there, you're going to want to change to change the improper fraction to a mixed fraction. Okay? Now, that's what it says right here. So you went to this, and now you're going to change the improper to a mixed fraction. Now, if you're confused on how to do that, that's back in the 6th grade. We learned how to do this where 14 over 3, that's really a 14 divided by 3, which means it'll go in 4 times, you'll get 12, and you get a remainder of 2, right? Now what do you do with the remainder? You put it over the original divisor. So 14 thirds, the improper fraction, actually changes to the mixed fraction 4 2/3. Everybody remembers that, right? Okay, so that's what we're doing. It says change the 14 thirds to a mixed fraction, and we end up with 4 2/3. So we have x to the 4 2/3 power. Now from here, we're going to split the base using rule 1 of exponents backwards. Now it's as simple as this. Your x is going to become 2 x's with multiplication between them. The whole number 4 is going to go on the first x, and the remaining fraction is going to go on the second x. Okay, that's the trick that we're supposed to know on this section. Okay, so once you get this, that's your answer, x to the 4th. But since this was a radical, let's change it back into radical form. It's always power over root. So this really says the third root of x squared. Does that make sense? So the answer, changing back to radicals, would be x to the 4th. And this is really the third root of x squared. So once again, let's review what we just did. We had the third root of x to the 14th. We changed it to the power over root as an exponent, right? That becomes x to the 14 thirds. There it is. And then you change that 14 over 3 to a mixed fraction. That becomes 4 2/3. There it is. And then we split the base using rule 1 of exponents. There it is. And then after that, we change it back to radical form. So that's simply x to the 4th, and this guy changes the third root of x squared. The third root of x squared. That's one way of doing it. I hope we all understand how to do it that way. That's the best way, quickest way of doing it. Now, if you are totally struggling with that, you might want to try this other option. Okay? So the third root of x to the 14th, you could rewrite the x to the 14th with multiplication to get powers of 3, because after all, on a third root, you want something with the power of 3, right? So you could go rewriting with multiplication. So I want to go x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd, and 2 more gives me a total of 14. And this is the third root. Now, why would I split it all up like that to the powers of 3? Because now I'm going to split up that third root, split the radical. And you're going to end up with the third root of x to the 3rd, the third root of x to the 3rd, the third root of x to the 3rd, so on and so on. And over here, third root of x squared. And then simplify each one of those. The third root of x to the 3rd is x. The third root of x to the 3rd is x, and so on and so on. And this guy, you can't do anything with it, so you leave it. And you really end up with x times x times x times x, which is x to the 4th times the third root of x squared. So it's two options on simplifying that same problem. So we definitely need to know at least one of these options to be able to simplify radicals. Let's move on.